Hey, it's me, Destin. Welcome to Smarter Every Day. So you know you're in trouble when you have to break out the Tinker Toys to explain a concept. What are you going to build?
Tinker Toy that scrubs and rolls over your hand.
Good idea. What are you going to build?
The sunset.
The sunset. Okay, so we're going to start building. Go. Alright, here at Smarter Every Day, we're right in the middle of a series on how helicopters work. And if you recall, I told you at the beginning that helicopters are very, very complicated. So here's the Tinker Toy helicopter that I just made. And if you recall from the other videos, I told you that as the blades on the helicopter spin around, they have the ability to change pitch as they go around in the rotor disc. Now this is called cyclic pitch. And if you don't understand this concept, you need to go watch this remedial video so you can remind yourself about what I'm talking about. So let's assume that we fully understand how that works. Here's the question. If I have a helicopter and I simply want to make a maneuver and I want to tilt the helicopter up and forward just like this, how do we change the pitch in the rotor disc? So to me, it's logical that I would want to increase the lift on the back of the rotor disc. So what that would do is that would cause more lift here, which would cause it to tilt forward. This makes sense to me. Does it make sense to you? Well, here's the deal. You're absolutely wrong if it does. This is why. You actually provide more lift on the side of the helicopter, and that will tilt the helicopter forward. When I first figured this out, it blew my mind because it just did not make intuitive sense. But it has something to do with this little gadget right here. You may have seen one before. It's called a gyroscope. So what does this have to do with helicopters? If you think about it, it's a big mass spinning very fast. Look at a helicopter. What do we have on top? It's a big mass spinning very fast.
So when the rotors are aligned with the helicopter body, if I wanted to pitch the helicopter body forward like so, I would expect us to be in phase right here, and I would expect to take less of a bite with this rotor and more of a bite with this rotor to rock it over. Is that what
That's
happened?
not the case. It does seem like that would be, but due to gyroscopic precession, any force on a spinning disc, which these blades do act as a disc, takes effect over a 90-degree phase. So if we give it a force here to push down or up to roll the helicopter forward, it'll actually take effect 90 degrees later and roll the helicopter sideways. So in order to roll it forward, we give the pitch on when it's 90 degrees away from.
Oh, so it's almost like predicting the future or something like that.
Something like that.
So if I wanted to rock the helicopter forward, I would take less of a bite when I'm 90 degrees out of phase and more of a bite over there, and that would do it?
Yep, so the blade here pulls up, this one pushes down, and it takes effect 90 degrees later when it's parallel with the machine, and the machine will rock forward like so.
Yeah, I'm not getting it either. In fact, I got a one-on-one explanation from an ex-pilot at the Smithsonian and I still didn't get it.
The control tube 90 degrees in front on the swash plug.
Like everything on Smarter Every Day, I finally understood this when I made an experiment for myself.
Alright, so Carl and I have set up a really super high-tech experiment involving bicycle wheels. Hey, the Wright brothers did it. It's good enough for me if it's good enough for them. And we have a camera aligned along a force application device, which is a metal strip. And do you want to explain what we got going on here?
Alright, we're going to...
Wait! I'm better. Go ahead.
We're going to apply a force straight up, and as you can see here, the tire rotates in the same plane as we're moving this bar. But when it's spinning, it's going to be different.
Let's just check it out. Yep. There we go. I used to play with my mom's exercise machine when I was like 5, so I'm highly qualified to apply angular momentum here.
There we go.
Angular momentum applied. It breaks.
Try to control this thing.
All right.
So now we're going to do the same test again. We're going to apply force straight up here, and it rotates 90 degrees from where we apply the force.
All right. This principle is called gyroscopic precession.
Correct.
And that's basically the force is applied orthogonal to the plane of rotation. It acts 90 degrees out of phase to that applied force. I think it's pretty interesting. So I have a plane of rotation here of the force, but it actually acts in this plane. And so if you look at the horizon that the camera's looking at, as he pushes up, it rotates opposite of that. It's pretty cool.
Yep.
Anyway, that's it. That's why helicopter blades operate 90 degrees out of phase. Got anything you want to add? Besides the fact that I was kneeling in a horse biscuit the entire time?
Good job.
Hey horse, what do you know about gyroscopic precession? That's what I thought.
So I realized this was one of the more complicated videos, and I hope you got it. If you would, leave me some comments and let me know so I can figure out how to best explain things in the future. Also, if you're interested, subscribe, because next week we're going to talk about the helicopter speed limit. And it's not because of the FAA, it's physics. I'm Destin, you're getting smarter every day.